In this problem, we are to take the following algebraic expression, divide it, and then simplify our answer. Before I start, I'd like to caution you that you should never cancel terms in a problem. If you don't know what a term is, here is my definition of a term. Any expression in a problem that's being added or subtracted, you can think of as a term. So for example, the 3 here is something that is being subtracted from the 5x. So I'm going to think of this as a term, and it is not correct to cancel this because it is a term rather than a factor. So let me show you what the common mistake is on this problem before I show you the correct way to do the problem. What is tempting to do, but is incorrect, is to say that the 3 is being divided by 3 and therefore it simplifies down to be 1. So the student wants to put a 1 here, or they simply cancel them and there's nothing there, leaving the answer 5x. So the answer 5x minus 1 or the answer 5x is the most common wrong answer to doing this problem. And the reason this does not work out to be correct is because you are not allowed to cancel terms, and the 3 is a term in this problem because it is being subtracted. If you want to see a numerical example to show why canceling terms does not work out to be the correct answer, wait till the end of the video and I'll show you a numerical example. For now, let me show you a correct way of thinking of the problem. The fact that the division bar goes across both terms in the numerator means that both terms are being divided by the 3, and that's one way to think about why you cannot cancel the 3's. If you cancel the 3's, you must be thinking that the 5x isn't being divided by 3 and only the 3 is. So the correct way to think about this is to think of it as the 5x, the first term in my numerator, is being divided by 3, and that my second term in the numerator, which is 3, is also being divided by 3. And then since they're being subtracted, I will subtract here. I often refer to this as breaking a fraction apart. It's the reverse of adding fractions. You're probably used to going from right to left. Many times you were probably given two fractions and you were asked to subtract the fractions, and to do that you were to find a common denominator. Mine already has a common denominator of 3. And then you were told to subtract the fractions. You subtract the numerators, 5x subtract 3, which is what I have here, and then you are not to subtract the denominators. You're just supposed to keep the common denominator of 3 and write it this way. So you're probably used to going from here to there, and hopefully that makes sense. The reverse of subtracting two fractions I call breaking the fractions apart. This shows that both the 5x is being divided by the 3 as well as the 3 here is being divided by the 3. Now you can write 5x over 3 as 5/3 x. They mean the same thing. And then now, since I have 3 divided by 3, you can simplify that down to be the number 1. 3 divided by 3 is 1, and don't forget that these two terms are being subtracted. So this is one way to approach the problem. Now earlier in the video I said if you wanted to wait till the end of the video, that's now, I can show you a numerical example why canceling terms does not lead to correct simplifications, but canceling factors does. So as a side example, I want to simplify the quantity 6 plus 3 divided by 3. We know one way to do the problem is to take 6 plus 3, which is 9, and then copy the division by 3, and then 9 divided by 3 is 3. So hopefully you agree that this original expression simplifies down to be the number 3. So if you are a person who likes to cancel terms, you may think that this 3 cancels with this 3 and that the answer would be 6, but clearly it is not 6. We've already stated that it's 3. Another common error is students want to say that 3 divided by 3 is 1. They don't cancel, they simplify down to be 1, and that student might think that the answer is 6 plus 1, which is clearly 7, which is clearly not the answer that's correct because we've already said that 3 is the correct simplification of this. So whenever you cancel terms, things that are being added, and the 3 was being added in this problem, so it's a term, you never get the correct result. Now as a second side example, I changed the operation from addition to multiplication. That makes the 3 no longer a term. Remember, a term is an expression that's being added or subtracted. Things that are being multiplied are called factors, and you can cancel factors and you'll get the correct answer. So for example, we know that the correct simplification of this is 6 times 3 is 18, and then 18 divided by 3 is 6. So the correct answer is 6. So for a person who likes to cancel factors, this is fine. You can think of it as the 3 is cancel, and you're left with the answer 6. But a better way to think of it is that 3 divided by 3 simplifies to be 1. So you're left with 6 times 1, which agrees with what we said is the correct answer here of 6. It may be helpful to think of it as breaking the fractions apart like I did in this problem. If you broke this fraction apart into its pieces, it's legal to think of this problem as 6/3 times 3. If you'd like, you could think of this as 3 over 1. Remember, when you multiply fractions, you do not need a common denominator. This would be 6 times 3, which is 6 times 3. And my denominator would be 3 times 1, or 3, if you were going from here to there. So here you could simplify things by saying that 3 goes into 3 once, 3 goes into this 3 once, and the answer is 6. Or you may think of it as 6 divided by 3 is 2, 3 divided by 1 is 3, and 2 times 3 is 6. However you'd like to think about it, my point is that factors can be simplified out by canceling and terms cannot.